Sampling in the sense what? It is a process of or a practice of analyzing the subset of all the data in order to uncover the meaningful information in the larger data set. Any value which is multiplied by 1.5 into IQR, then that will be considered as what? Outliers. This standardization only for the regression based approach. We are not going to use this standardization of data for the decision tree. Hello everybody, a warm welcome to one and all. I am Rohini TS from the Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So in our today's session, we are dealing with a B.C.A's final year, that is semester 5 of a subject called Cloud Computing and Big Data Analytics, and we are in the unit 4 of a session 1. And unit name is Data Preprocessing and Analytics. So here you can see the syllabus copy of this unit 4. So in this today's session, we will be starting with a unit 4, that is Data Preprocessing and Analytics. So we'll see the first topic, that is related to Data Preprocessing overview. As we all know that data and information will going to play a very important role in the organization, so that the cleaning of data, that means the data and information that we are going to use in an organization should be very clean. So it is not in the terms of cleanliness. The clean in the sense what? I just wanted a data and information which is relevant for my organization or relevant for any of the organizational activities. So it is necessary in order to process the data. For that purpose, we are going to have this pre-processing. So data is nothing but it is a raw fact, and data can be anything. So I can take the example of text, numbers, or any of the images, videos, audios. So that will be considered as a raw fact. So if I wanted to make that as an information, then it has to be process, so that in the data pre-processing we are going to take some measures in order to have only the relevant data, and it must be clean. Clean in the terms of what? It must be relevant and it must be accurate, it must be flexible. So in that manner we are going to deal with the data pre-processing in the big data analytics. When I am considering that as a big data analytics, it will going to deal with a large number of data. So if I am giving only garbage values, then it will also going to give the resultant as a garbage only. That means garbage in, garbage out. So we have to give the data and information which is accurate in nature, and it must follow some quality data. Then only we can expect good result out of that data. So here, for that purpose, we are going to have a sampling. So sampling is nothing but it is the practice of analyzing a subset of all the data in order to uncover the meaningful information in the larger data set. Sampling in the sense what? It is a process of or a practice of analyzing the subset of all the data in order to uncover the meaningful information in the larger data set. So I have a larger data set. Within that larger data set, I am just picking the data and information which is required. So we are analyzing in the terms of accuracy, in the terms of speed, flexibility, and whether it is a qualitative one or whether it is required for my organization or whether it is required for my big data analytics. By keeping all those points in our mind, we are just doing analysis. So we are collecting some of the samples, we are collecting some of the data elements in some of the set of elements. That process will be termed as what? Sampling. And also the main aim of sampling is to take a subset of past customer data and use that to build an analytical model. So as we got to know that previous data or historic data and current data will going to be used in order to make a future decision, so that it is necessary to hold or it is necessary to keep the data which is already analyzed. So if I am having the data which is already analyzed, polished, everything is done, then that will be easy for me in order to make a business decisions, and that will help us in order to have a better analysis. So key requirements for a good sample is that it should be representative of the future customer on which the analytical model will be run. So if I am using historical data or a current data, that must help me to make a decision for the future. So if it is not relevant to the futures, or if it is not going to satisfy the requirements of a future expectation, then that kind of samples we don't require in the business or a big data analytics. So when we are doing this sampling, at that time it must be very fast. So that means you should not spend much time in order to have the data elements. So it must be very accurate and it must be very fast. It should not be biased in nature. So it should not be biased in nature. That means it should not be like hide and seek. So if the data is not correct, if the data is missing, that has to be represented as it is. So main concern about this sampling is what? Which will going to discover or uncover the hidden data or hidden content of a data, and you should not take much time in order to do the sampling, and there should not be bias. That means there is no hide and seek game will supposed to be play with the sampling. And also here we have some types of data elements. So I'm just going to collect different types of elements. So it is necessary to categorize the data element. The following types of the data elements can be considered. That is what? First type is continuous. So how can I say data element is continuous? So when that data elements that are defined on an interval that can be limited or unlimited. There must be a interval between one data elements to another data element. So it must be continue, and that data element interval can be either limited or unlimited, but it has to be continue in nature. What are the examples we can take? Incomes. So income must be continue, whether you can get a salary for 2 months or for 4 months or on the monthly basis, that can be anything, but it must be continuous, and also related to sales. Okay, so these are the examples that we can take for the continuous data elements. Next we have a categorical. So in this categorical we have a first type, that is nominal data. So these kind of data elements that can only take on a limited set of values with no meaningful ordering, in between. So if you take an example of a loan, so that loan amount can be used for any kind of purpose. For example, you will be taking educational loan, but that amount can be used for what? Any purpose. Like you can use that amount for the entertainment purpose, that you can spend on any of the accessories. So that kind of things can be takes place. So here nominal in the sense, these are the data elements that can only take on the limited set of values. For example, as I told, if you wanted to take any of the loan, there will be limitations, like for home loan, for educational loan. So for all those things there will be a limit of values will be there with no meaningful ordering in bit. I can use that for any of the purpose. So if you consider the example of marital status, it can be anything, like it can be unmarried, married, divorced. Okay, there is an interval, but there is no meaning in between. So that kind of values will be termed as what? Nominal. And profession, purpose of loan. So purpose of loan can be anything, but the amount will be limited values. Next we have a ordinal. So these are the data elements that can only take on a limited set of values with a meaningful ordering. So here we have a meaningful ordering, but in the nominal we don't have, but in the ordinal we have a meaningful ordering in between. So you can take the example of age. So there will be a limited set of values. For example, I will consider 100 will be the limit. Okay, so at that time there will be an interval between one data to another data. So what we are going to use? So at that time we can take the age, like young age, middle age and old age. Okay, so there will be a meaning from one interval to another interval, and you can take the example of credit rating also. And we have a binary. So binary in the terms of it will going to give the values either true or false. Only two values are possible. So these data elements that can take on only two values. So here gender and employment status, whether they are employed or unemployed. Next we'll see about the next topic, that is missing values. So why the values will going to be missed? As we all know that we are dealing with a big data analytics. So there should not be missing of any values. So if I am missing any of the values, then that could also lead me to get resultant which is not as expected. So that will going to remove, or that will going to reduce the quality in the analysis or a result. So that missing value can occurs or happens for various reasons. So that can be what there will be various reasons, like they have missed the data, they have lost the data, and some other data has incorporated. So there could be more situations in order to get a missing values, but the information can also be undisclosed. So along with that, information can be non-applicable. So if you have a missing values, then the information is not applicable. But we have several methods in order to recover or in order to make a changes to the missing values. So the following are the most popular schemes to deal with the missing values. What is the first type? Replace or impute. That means this implies replacing the missing value with known value. So we can replace the missing value with known value. For example, if anybody is taking interview about my student, I know what is that student is all about, what is their status, everything we know. At the time, if somebody is asking what is her number, for example, that number column will be, you just imagine that number column is empty or a missing. So if I know her number, I can give it to them in order to fill the data. So that means what? We are going to replace the missing values by known value. So if anybody asks about the marital status of a student, at that time we know that whether they are married or not. Then if it is missing in the column, we can give some value which is already known to us. So that is related to replace or impute. And another one is delete. So delete in the sense what? If I consider that column is not so important, if I delete it, it won't affect on the data, then at that time I can delete that. That can also be takes place. So this is the most straightforward option and consists of deleting the observation or a variable with lots of missing value. For example, if I consider a marital status of all the students, so if they don't wanted to disclose, or if they don't wanted to disclose their parents' salary, at that time, if most of the students are not ready to disclose their parents' salary, at that time we will just cancel that column. That is related to delete. That is related to keep. Here missing values can be meaningful. So all the time somehow missing values can be meaningful. How it will be meaningful? For example, if I ask any person regarding their employment status, but you just imagine they were working earlier days, so now they are not working. That means they were employed before, but now they are unemployed. At that time, instead of asking them, I will just keep that column as a blank, or I will just keep that as it is. Then we can fill that missing values further. Those are the three methods in order we can replace, we can delete, and we can keep. We'll see the next topic, that is outlier detection and treatment. So here first we have to understand what do you mean by outlier and how can I detect it and what is the treatment for these outliers. So here outliers are extreme observations that are very dissimilar to the rest of population. So what I will be calling it as an outlier. So when there are set of data elements or when the set of observations that are very dissimilar to the rest of population, then we are going to call that as a outlier. So why it is necessary in order to detect and treat? Because if it is not similar, or if it is not belongs to particular category, then having the garbage for the big data analytics will going to create some of the nonsense activities, or it will going to reduce the quality of a data. So that it is necessary in order to detect the outliers, which is not so necessary for the analysis. So there are two types of outlier can be considered. One is what? Valid observation, and another one is invalid observation. So if I consider a valid observation, so salary of boss is $1 million. There could be a possibility, but I can consider that as a outlier. Why? Because somehow that is not possible. Okay, but there could be a possibility. But here it is a valid observation. For example, if you are considering only between some value, like if you are considering the salary only between $5,000, at that time, if the value is $1 million, that is out of my range. At that time, we will consider that as a outlier, but it is a valid observation. And we have a invalid observation, like if a person age is 300, can we believe that? Absolutely no. So this is what it is not at all possible, and it is invalid in nature. So these are the two types that we have in the outliers. Along with that, valid observation and invalid observation both are univariant outliers in the sense that they are outlying on only one dimensions, like that can be either related to age or can be related to salary. So they are only relying on a single dimensions. However, outliers can be hidden in unidimensional views of the data. What if I wanted to have one more dimensions like a multi-dimensions? At the time, multivariant outliers are observations that are outlying in multiple dimensions. At that time, it has both a row and column as well as it has a depth. Okay, we are going to have height and width along with a depth that is related to multiple dimensions. Here you can see the example. Here we have a income versus age. Here we have a income in the terms of dollars. Okay, so if you consider this 20, at that time they may not started earning. Okay, then when it reaches to the 20, they can start earning $500. So as the age goes up, the salary will going to be high. And if you consider the person with the age 20, if they are earning $4,000, somehow it seems that it is more dissimilar than the rest of the population. At that time, we are going to consider this as a outlier. So here also you can see that the person in the age of 60, they are earning $3,500. Along with that, the person in the age of 70 is also earning more than $4,000 in the age of 70. That means we are going to consider only these values because these are the valid observations. Okay, so this will be dissimilar to the rest of the observation, then it will be considered as what? Outliers. And also we have important two steps in order to deal with the outliers. First is what? I need to detect it and I have to treatment for the outliers. So if we keep the outliers as it is, then there will be a possibility of having a garbage values, because which is not similar or which is not required for the data analytics, if we are keeping with that, then that is also one of the challenge. So that first we have to detect and we have to treat. So the first type is what? Detection. The check for the outlier is to calculate the minimum and maximum values for each of the data elements. First is detection. So I have to detect. After detecting that, I have to set a threshold like which is the minimum value, which is the maximum value. So if any value which is comes even after the maximum comes before the minimum will be termed as outlier, because I have a range between minimum and maximum. If the data element is not in that range, then that will be outliers. And also the various graphical tools can be used in order to detect the outliers. We are going to use histograms as an example in order for the outlier detection. So here you can see that. So here also we have a two dimensions. One is age and another one is its frequency or income. So here we have a 0 to 5 and 20 to 25, 25 to 30, up to we have 150 to 200. So this is related to age. And also here we have a income in the terms of dollars. Okay, 0, 500,000, 1,500, 2,000, 2,500, 3,000 as well as 3,500. So here you can see that in the age of 0 to 5, they are saying that any of the person or a person with a 0 to 5 age, they are not learning or they are not gaining anything. That means they are not taking a salary. And here also we have a people between age of 150 and 200, and we are stating that they are not earning or they are not getting any income. So if you think in a broader manner or if you think it in a direct way, at that time, so nowadays nobody will going to be alive up to 150 to 200 years. So that will be considered as what? Invalid observation. Here also, if a person or any of the people, those who are started earning between 0 to 5 will be termed as outlier. So this one will be the outlier and this one will be the outlier. Okay, this will be the valid outlier. There is no possibility of earning at that age, but this age does not exist. The people won't live up to 150 to 200 years. Though they are alive, they can't earn it. So that will be considered as what? Outlier. Histogram will be used in order to depict the outlier. So this is also called as bar graph or a bar chart. We have one more method, that is another useful visual mechanisms or box plots. So we can use histogram and we can use box plot that represent three key quartiles of the data. One is what? The first quartile is 25% of the observation, that will be considered as a lower value, and we have a median, that is 50% of the observation have the lower value, and we have another third quartile which is of 75% which has a lower value. Okay, so I will show you that. Here you just consider that is quartile 1, and we have a median, and we have a Q3. So in order to find the outlier, here I am going to multiply 1 into 5 into IQR. Then how we are going to find this IQR? That is the maximum minus minimum. So if I am finding the space between, or if I am finding the range between Q3 up to Q1, this will going to help me in order to cover all the data elements. So if any element which is multiplied with this particular subtraction value, or the difference between Q3 and Q1, that will going to give us IQR. Any value which is multiplied by 1.5 into IQR, then that will be considered as what? Outliers. So here up to 1.5 into IQR, I can get up to this range. So if I have any element here, or if I have any data elements here, then it will not be considered as an outlier because it is within the range. And here I have 3 data elements which is out of range. So it will be considered as what? Outlier. If I have any values which is out of range like here or here, which is lesser than the Q1, so that is also be considered as what? Outlier. This is one of the method, that is box plots. We'll see the next one, that is another way is to calculate the z-scores. So it is measuring of how many standard deviations an observation lies away from the mean. So here we are going to find the mean value, then how many values are away from that mean will be considered as what? Outliers. Then how we are going to find that? Zi is equal to xi minus mu over standard deviation. This is the formula which will going to be represented or will be used in order to find the outlier detection. So here mu represents the average of the variable and standard deviation is the standard deviation. So here you can see that if the standard value which is going to be exceeds more than 3, which is going to be exceeds more than 3 will be termed as outlier, which is within the range will be termed as the data elements which is belongs to the particular category. And also the practical rule of thumb then defines the outliers when the absolute value of the z-score z is bigger than 3. As I told, if the z-score is bigger than 3, so here you can see that if any value which is bigger than 3 will be considered as what? Outlier. So that z-score relies on the normal distribution. This is regarding what? In order to detect the outliers which is of univariant outliers. So these are the methods which will going to focus us on the univariant outlier. Then who is going to take care about the multivariant outliers? That is, multivariant outlier can be detected by fitting regression lines and inspecting the observations with large errors using, for example, residential plot. So for example, you consider here I have some of the data set. I will just going to put one line. So the value which is comes under here, or the values which resides that side will not be considered. Like if I am going to give some parameter, based on that the values which lies to this particular line will not be considered, or if any value which comes to this particular separations or a classification, then it will not be considered. That will be considered as what? Outlier. So we are going to have a regression lines, and we have another alternative method, that is clustering multivariant outlier detections, and also some analytical techniques that includes decision tree, neural network and support vector machine, that is SVMs, commonly used techniques in order to find the multivariant or multivariate outliers. And also we have other things like linear or logistic regressions, or more sensitive them. So mainly we are going to use a detection method of a outliers which will be based on whether the outlier represents a valid or invalid observations, whether it is a valid observation or invalid observation. Based on that we are going to choose any of the analytical method or any of the outlier detection method. As we discussed, we have a valid or invalid observation. So if it is invalid observation, for invalid observation like age is 300 years, there is no possibility. At that time, one could treat outlier as a missing values. So at that time, I will just remove that age column from the data analytics, because that age is not going to be satisfy the requirement. So that will be considered as a missing values, and we can use either standard deviation method or Z-scheme method. So anything in order to deal with a invalid observation. What we are supposed to do for the valid observation? So here income is $1 million. So there could be a possibility of getting this salary. But here other schemes are required in order to deal with a valid observation. So it includes truncations and capping or winsorizing. These are the methods we have in order to detect the outliers. So here you can see the illustration. So here we have a mu minus m 3 standard deviations, and we have a mu that is median, and mu that is median plus 3 standard deviation. So any value which is greater than 3 or any value which is lesser than 3 will be considered as outlier. So we are using Z course for the truncation. That means we will be concentrating only on the whole numbers by leaving all the fractional part. And if you wanted to have a capping, the sigma transformation ranging between 0 and 1 can also be used for the capping as follows. So we are going to use this formula, that is f of x is equal to 1 by 1 plus e power minus x. So this method will be used in order to do the capping. This is regarding what? Outlier detection as well as the treatment. So now we'll see about the next topic, that is standardizing data. So why the standardization of data is required? Because we are using this data for the analysis. So standardizing data is a data pre-processing activity targeted at scaling variables to a similar range. I just wanted to make a group of similar range. I wanted to make a group of similar data. So for that purpose, we are going to make it as standardized. So that is the reason of having standardization of a data. So you consider an example, like there are two variables. One is gender, that will be coded as 0 or 1, and we have income which range between $0 to $1 million. Okay, so when building logistic regression models using both information elements, then the coefficient for income might become very small. So at that time, this value will going to be considered as very small. So when I'm using this regression model, so regression model in the sense what? I'm just going to use some of the values, for example in the terms of age and in the terms of income. Okay, so if it is related to 0, at that time we are not at all going to consider that. So that will be the coefficient for the income might be very less. So it could make a sense to bring them back to a similar scale. So I have to make it standardized. For example, the age must be greater than 20. So if you consider India and any other countries, at that time earning will going to be start with a minimum of 15 years. Let me consider 15 years. Okay, and the income will going to be starts from 10,000 or 15,000. So we are making that age and income as a standardized data. Then only we can get the resultant as per the requirement. For that purpose, we require a standardization. So here the following standardization procedures could be adopted. So we have to take minimum maximum standardization. We have to make which is minimum, which is maximum. If the data elements which resides in between that minimum maximum range, then we can consider that data is standardized. So that x new is equal to x old minus minimum of x old divided by maximum of x old minus minimum of x old of new max minus new min plus new min. This is a formula in order to make the standardization of a data. And here new max and new minimum are the newly imposed maximum and minimum data. So maximum will be 1, minimum will be 0. So the values which is going to be related only between 0 and 1. And also we have a Z-code standardization in order to calculate the Z-codes. Already we are done with the Z-codes in the previous slides. Same thing will be applied in order to make it as a standard. Next we have a decimal scaling. So here dividing by a power of 10 as follows. So we are going to divide a given value by power of 10 values, that is x new is equal to x whole divided by 10 power n. So n will be the number of data elements. So here with n, the number of digits of the maximum absolute value. So if I am taking 60 data elements, or if I am taking 60, the element needs to be standardized, then 10 power 60 it will be. Remember one thing, we are going to use this standardization only for the regression based approach. We are not going to use this standardization of data for the decision tree. I hope you all understood my today's session. Let me meet you in the next session with a continuation of Unit 4 itself, that is data, pre-processing and analytics. Until that, keep learning, keep on growing. Thank you.